Binomial multiplication and special products. This video will help you multiply two binomials and recognize the answer patterns in special binomial products. Multiply two binomials. Let's start with an example here. In this example, I'm asked to multiply. And let's take a look here. And what I'm actually multiplying here is two binomials. You'll notice this first thing that I have in parentheses here, this first factor that I have in parentheses there, has two terms in it. And that means that we have a binomial there. Binomial meaning two terms. The second factor that I have here, 3x plus 5, again, that has two terms, so that's another binomial. Notice I'm calling each of these factors because both of these binomials are getting multiplied together. And I know that because I have two sets of parentheses right next to each other. And when we write parentheses next to each other, that means multiplication. So what this is asking me to do is to multiply everything in this first set of parentheses times everything in this second set of parentheses. So the way that we do that is we kind of do that in an organized fashion. What I'm going to do here is I'm going to use the distributive property twice. Let's write this down again. So I have 2x plus 1. And I'm multiplying everything in there times everything in here. So what I'm going to do is I'm going to just do this in organized fashion. I'll use the distributive property, meaning I'll just distribute this 2x first. I will go through and multiply that 2x times each of those terms on the right. Secondly, I'll go through and distribute this positive 1 and multiply it times those two terms. When I've done that, then I've multiplied all four of these terms together, and I've multiplied everything in both sets of parentheses. Now, using this distributive property twice is a great idea, but later on we're going to go kind of turn around and undo this multiplication. And when we undo that multiplication, it's going to be important to identify each of these individual multiplications. And so we use this little statement right here, FOIL, to kind of guide us through this. And so this kind of tells us the order of things that we're going to multiply here. And so you notice it says firsts, and that would be this 2x getting multiplied by this 3x right there. That would be the first two terms that appear in these binomials. And then we would do outsides next, meaning the outside terms in this. And you can see that this is the 2x times the 5 there. Those are kind of our outside terms there. Then insides would be this 1 times the 3x. There are my inside terms here. And then finally, lasts are the things that appear in the last spot, and that would be the 1 times the 5. So no matter if we look at this with this FOIL instruction or we look at this as the distributive property twice, the multiplication works out the same. So now let's go ahead and take a look at this multiplication. So first I would distribute the 2x. Well, 2x times the 3x is going to give me 6x squared. Now I'm still distributing that 2x, so I would say 2x now times a positive 5. 2x times positive 5 would give me a plus or positive 10x. All right, continuing on, I'm kind of halfway done. I've distributed the 2x. Now I'm going to distribute the 1. 1 times 3x, that's a positive 1 times a positive 3x. So that is going to be plus or positive 3x. And now 1 times positive 5, that's going to be a plus or positive 5. Okay, so I've multiplied this out. Now I just want to make sure see if there's anything else I can simplify here. And I do. I have some like terms in the middle here, and you'll notice this positive 10x and this positive 3x. Those are like terms, so I could combine those together. So this would be 6x squared plus 13x plus 5. And that's the best I can do. Notice the x squared and the x term can't be added together, and neither of those x terms can get added with that constant term of 5. Let's practice multiplying a couple binomials here. And while you're doing this, let's go ahead and use this FOIL method. This is a technique or a way to think about it that you're going to want to get used to. So go ahead and use that as you multiply these two binomials. Go ahead and pause your video player now and do this practice question. When you're done, hit play to see how you did. Okay, let's take a look. We're multiplying two binomials, 3x minus 1 and 3x minus 1. So you notice we're kind of multiplying the same binomial here twice. So we're going to do firsts. That would be the first 3x times 3x. 3x times 3x would give me 9x squared. Okay, outsides, that would be the 3x and the negative 1. Well, a positive 3x times a negative 1 is going to give me a negative 3x. All right, insides, that's going to be our negative 1 and our positive 3x. Well, a negative 1 times a positive 3x is again going to give me a negative 3x. And then finally the lasts, that would be negative 1 times negative 1. Well, a negative times a negative is going to give me positive, so that would just be positive or plus 1. Again, notice how those like terms are right next to each other, the negative 3x and the negative 3x. So that would be 9x squared minus 6x plus 1 for our answer. Okay, now let's go ahead and practice another binomial multiplication. You notice here I have this 2x plus 5 squared. Students might be tempted, or are often tempted, just to take and square each of these terms. Square the 2x, square the 5. That's not going to give us the correct answer, because what happens is we'll miss our middle term. If I had something like this, 2xy squared, where everything is just one term in there, then I can go ahead in this multiplication problem and just go ahead and square each of these three factors. Because notice here they're factors, they aren't terms. This is all getting multiplied together. So the answer to this would be 4x squared y to the fourth. Students are often tempted just to distribute this 2 to each of these terms, but that won't work because now I have two terms. So go ahead and write this multiplication out longhand and multiply the two binomials. When you're done, hit play to see how you did. Okay, let's take a look. So we should have 2x plus 5 times 2x plus 5. Alright, so let's see. Firsts, the 2x times the 2x would give me 4x squared. Outsides, 2x times a positive 5 would give me a plus or positive 10x. Insides, positive 5 times positive 2 is again going to give me a plus 10x. And then finally, a positive 5 times a positive 5 is going to give me a plus or positive 25. Our like terms right together in the center there, so we have 4x squared plus 20x plus 25. Special products. In mathematics, we often look for patterns to help with our understanding and to make problems easier. Here we're going to investigate binomial products that have easily recognizable patterns in the answer. Let's go ahead and take a look back now at practice question 2 and practice question 3, the ones we just kind of did there. Notice in both of those practice questions we had the same binomial times itself. The first one, practice 2, notice I gave you 3x minus 1 times 3x minus 1. I wrote the multiplication out long form. And notice in the next one, I gave it to you as this is just 2x plus 5 squared, or 2x plus 5 times itself. So notice in each of those cases, I'm taking a binomial times itself, or if we want to kind of look at the general form here, a plus b squared. And anytime we look at the square of a binomial, there is a pattern in the answer. We actually don't have to go through and multiply all of this stuff out. We can kind of use this pattern to quickly come up with the answer. Let's look at our answer here in practice question 2. The first term, 9x squared, where did we get that 9x squared from? Well, we kind of got that from the firsts here, 3x times 3x. Or another way to think of that is 3x squared. That gave us that first term of 9x squared. Now let's take a look at that last answer we got, positive 1. Well, the way we came up with that positive 1 is we took the last multiplied together, the negative 1 times the negative 1, or again, negative 1 squared, which then ended up giving us a positive 1 on the end. The middle term is a little bit harder to see, but notice the middle term, negative 6x, repeatedly adding these terms together. Negative 3x and negative 3x together. Notice negative 3x was the outsides, 3x times negative 1, and then the next negative 3 was the insides, negative 1 times 3x. But notice those are identical, negative 3x and a negative 3x to give us negative 6x. So really what we did there is if we kind of take the outsides times the insides, or 3x times 1, and then double that, we're going to get this, in this case, negative 6x. And that one is hard to see. That middle term is a little bit harder to see. Let's take another look now at practice 3. The first term, 4x squared, we could get that from 2x, from squaring the first. 2x times 2x would give us the 4x squared. The last term comes from squaring the last one. 5, 5 times 5 gives us 25. Now let's come up with this positive 20x in the middle, and see how we come up with that. Notice again it was kind of these two factors multiplied together, 2x times 5, but then we're going to have two of those. That result there is 10x. So what we're going to do is we're going to get two of those to give us a middle term then. 2x times 5 would give us 10x, times 2 again would give us 20x. And that certainly gives us the middle term. We can kind of highlight it here to see that we need two of these, and by the fact that we're adding this 10x and 10x together again. So people that have studied math before us notice when they were multiplying these binomials, there's a certain pattern. So what we do in mathematics when we recognize a pattern that's going to make things easier for us to understand or easier to do the problem is we generalize. And so over here is our generalized form. And we have one for both addition and for subtraction. Notice if I have a number, any term here, I'll kind of cut this off here, any term a plus b and I square it, I can go directly to the answer this way. Instead of writing it out and multiplying it out, I can simply get the answer by the first term being a squared, the last term being b squared, and the middle term doubling this a times b, or 2ab. Same thing again if we're subtracting in this binomial. It's very similar. To get the first term I take a squared, to get the last term I take b squared, which is identical to the positive or plus 1. Now the middle one is almost identical as well, except we just vary by a sign. The middle term is then going to be negative 2ab. Now it's time to practice using these generalized forms to quickly multiply a squared binomial. Even if you had trouble following or recognizing the pattern as I talked through it in that last clip, go ahead and use the form. It's a lot easier to use than it is to identify the pattern. So notice I've given both of the forms down here. I've given you one when we're adding to in our squared binomial, and then one where we're subtracting. Go ahead and pause your video player now and use these generalized forms to multiply these two binomials. When you're done, hit play to see how you did. Okay? Practice question 4 here. I'm squaring this binomial, 4x minus 2, so I want to use my subtraction form there. So to get my first term here, we'll just kind of come down below it. To get my first term, I would say, okay, take a squared. Well, a in this case is this 4x. So square 4x, I would get 16x squared. Now let's go to the middle term. The middle term is going to be negative 2ab, right here, negative 2ab, which means it's definitely going to be negative. And then I'm going to take twice 4x and 2. So if I take 4x times 2, that's going to give me 8x. If I take twice that, that is going to give me 16x. All right, the last term then is just plus b squared. So I need a positive sign here. B in this case is 2, so 2 times 2 is going to give me 4. And so there is the answer to that binomial squared. Okay, practice question 5. Here I'm again multiplying two binomials that are exactly the same, where we're squaring this binomial, except now I want to use my addition sign. So let's see, if I come down here, I'd say, all right, first term is going to be a squared. Well, 5x times 5x gives me 25x squared. Next term is going to be 2ab plus 2ab. In this case, 5x times 3 is 15x. If I double that now, that's going to be 30x. Last term is going to be 3 times 3, or 9. Now we're going to take a look at the sum and difference of identical terms. So the generalized form of that would be, a plus b times a minus b. I have it written right here. We have identical terms, but in one case, the binomial, it's addition. In the next case, it's subtraction. What I want you to do is go ahead and multiply in 6 and 7 as you normally would multiply binomials. Either use the FOIL method or the distributive property twice. Go ahead and multiply these together and see if you recognize a pattern. Once you recognize this pattern, I'd like you to come down here and write the generalized form for the sum and difference of identical terms. Go ahead and pause your video player, multiply these two, and see if you can see what the pattern is. When you're done, hit play to see how you did. Okay. Question 6, we're just going to multiply this through. So the first thing I would do is distribute the x. So that's going to give me x squared minus 2x. Now I'm going to distribute the positive 2, and that's going to give me plus 2x minus 4. Now I'm looking for like terms to combine, the middle terms right there, And so negative 2x plus 2x is going to give me 0. So all I'm left with there is this x squared minus 4. Okay, let's take a look at the next one. Distribute the x. That is going to give me x squared minus 6x. Now I'll distribute the 6. That's going to give me positive 6x and then minus 36. Okay, like terms again right there in the middle. A negative 6x and a positive 6x is going to give us 0. So really what I'm left with there is x squared minus 36. Okay, hopefully you notice at least one pattern there, and that is that the middle term is dropping out for us every time we do this, right? This negative 2x and positive 2x kind of went to 0 here, and then this negative 6x and positive 6x went to 0 there. So that is one thing to recognize. The only other two things we need to recognize is how do we get the first term? How do we get the last term? Notice the first term, x squared, was simply just x times x, or just simply squaring that first spot. Notice the last spot, the negative 36, comes from 6 times 6, or 36. And then notice they both have a subtraction sign in the middle. So now let's go ahead and try to write this generalized form out. Notice our first term was x squared, whatever that thing is in that first spot. So if I had a and a, that first spot is going to be a squared. The middle term now is going to drop out entirely. It ended up being 0 both times. So the last term is simply going to be b squared. And you'll notice in each of these cases we had a subtraction sign. So there is our generalized form when we have a sum and difference of identical terms. It's just simply a squared minus b squared. So as we are working through these special products, you may have asked yourself, do we really need to know this stuff? I mean, I can just simply take the two binomials and multiply them together to get my answer. Well, you can multiply these two together, and if you do forget the special products that we're talking about today, you can always just multiply them together. But not long from now, we'll be reversing this multiplication process and doing something called factoring. And when we get to factoring, recognizing these special products is really going to come in handy. Let's go ahead and take a little preview into factoring and see what that actually means. So I've given you two examples. The first one here is simply with a number. So when I factor something, like in this case 10, what I'm doing is I'm splitting it up into factors that multiply together to give me this thing. So in this case, when I factor 10, I get these two factors, 2 times 5. And so essentially right here I've factored 10, writing it as 2 times 5. So now what we want to do is we want to kind of transition that idea of factoring 10 into factoring these polynomials that we've been working with. Notice we started, when we multiplied, we started over here, x plus 3 squared, and then we'd write it out. This would be the next step. Write it out as x plus 3 times x plus 3, and then come up with our answer over here, x squared plus 6x plus 9. Or if we recognize right away this special product, we could go right from this x plus 3 right over here to our kind of multiplied answer. Well, what we want to do now when we factor is reverse this. We are going to start with this x squared plus 6x plus 9 and write it as a product of multiplication here. Essentially factor it. And so when we're factoring, it's going to be really handy to recognize this. When I look at this trinomial right here, I quickly and clearly see that that is just a binomial squared. So I could go directly from here right down to this answer here, in the factored form of this is x plus 3 squared. You'll be able to factor these things too pretty quickly, as long as you recognize these trinomials, or our answers here, are some form of a special product. So now I'm going to have you go ahead and try to factor these things using these generalized forms of special products. So you may get them right, you may get them wrong, but either way, it's good to go ahead and give this a shot, or give it a try, because that's how we learn to do things. So go ahead and pause your video player and try to factor these things. I'm giving you the generalized forms down here as to how these things are going to factor. I think if you use those generalized forms, you'll be able to get these things factored. So go ahead and pause your video player now and answer these questions, and when you're done, hit play to see how you did. Okay, let's take a look. Practice question 8. I'm asking you to factor this trinomial. Notice we have some term here, some x squared term, plus 8x, plus 16. Let's look down to our generalized form and see which one that matches up with. That matches up with this one right here. You know, we have all addition signs. We have three terms. We have all addition signs here. Let's see if it kind of matches where this is a squared and 2ab and b on the end. So let's see. Let's start with a squared. What would a squared be? In this case, you know, when I'm going back the other way, I'm thinking that maybe this will work out to be this sum or a square of a binomial with an addition sign in the middle. So let's see what a squared would be. A squared is x squared in this case. So if I wanted to write that as just a one factor, x squared, that would mean I need an x here. Now let's look at the last term there, 16. 16 is a perfect square. 4 times 4 would give us 16. So it looks like maybe I could put 4 in the middle. Now let's just make sure that this is 2ab in the center. So I'm thinking 2 times both of these things multiplied together. X times 4 multiplied together. Well, x times 4 is simply 4x. 4x times 2 is going to give us 8x. And so sure enough, that gives us the middle term. So this is the correct factoring of that first trinomial. Let's take a look at the next one here. X squared minus 6x plus 9. Let's see our generalized forms down here. This kind of matches up with this one right here. A squared minus 2ab plus b. Let's see if it works. So I need my 2 in the middle. My final factored form is going to look like this. A minus b squared. So let's put a minus sign in between there. Let's put a squared up there. Figure out what our a and b would be. Okay, so the first term, x squared. Well, that would just be x times x. So I can put x there. Last term, 9. That would just be 3 times 3. So this would work for the first and last. Let's see if it works for the middle. So what we want to have is 2ab. So 2 times x times 3. Well, 3 times x is simply 3x. 2 times 3x gives us 6x. So sure enough, that checks out with the middle term there, right? Notice this form, a minus b, in this case x minus 3, will give us this first term positive, second term negative, last term positive. And that's what I have here. So there's the correct factoring of that. All right, let's take a look at 10. X squared minus 25. Notice there's only 2 terms there. The middle term is dropped out. That kind of looks a lot like this last one there. So I'm thinking, okay, we're going to have the sum and difference of identical terms here. So let's see, a would just be x, because x squared, a would just be x. So I need x and x. My last term is 25, so square root of that or would be 5 times 5. And let's make sure that that middle term is going to drop out and give us 0. Well, to get the middle term, we do outsides, which would be negative 5x, plus the insides. 5 times x gives us 0. The middle term drops out, so sure enough, there's the factoring of that one.